Lesson 14.7, find average value graphically given areas. This lesson takes the last lesson just one little step further. Anytime you hear the word average, if you're going to average scores, your test scores or your homework scores, or in baseball they have averages, you're adding numbers up and dividing by how many numbers there are. So what we're doing is the exact same thing where we're going to have an integral from x value to x value of a function, but then we're going to have to divide by how many x values we're covering. So that is found by taking the b minus the a. I use this, but you'll see Delta Math use this. Well, dividing by that is the same as taking 1 divided by that. It's kind of like if I divide by 2, that's the same thing as taking it times 1/2, 1 over 2. You pick which way you like. So number 1 says regions A, B, and C in the figure below are bounded by the graph of the function f and the x-axis. The area of region A is 20. Love these when they tell us. B is 12. And C is 13. What is the average value of f on the interval from -8 to 8? So we're going from here to here, covering the whole thing that they gave us. So what we're trying to do, if we wanted to put it into the notation, we would say we're going from x values of -8 to 8. This function is called f, so f of x with respect to x. But then I'm going to have to average it, so I'm going to divide whatever number I get for the area by the b minus the a. Well, that turns into positive, so really I'm covering 16 units when I go from -8 to 8. So that should make sense. The area here would be 20 plus 12 minus 13. And then I'm dividing that by 16. That would be what? That would be -1. So 20 minus 1 is 19 sixteenths, and 19 is prime. So that would be the simplest form. So again, this lesson is exactly the same, other than you have to take it one step further and average it by dividing by the b minus the a, or how many x values you're covering. The other thing I want to talk about is what you're actually finding here is an average value. So we're not finding an average slope, we're actually finding an average y value. It's like I'm averaging this number and this number and this number, averaging all of the heights to get 19 sixteenths, which is a little over 1. So that's kind of cool too. It's almost like you're finding the average. I mean, that's what you're doing. You're finding the average of, if I were to have the ordered pairs or the coordinate points of all these points, and I took all the y values and I added them all up and divided by how many numbers. That's essentially what you're finding.